Hello, everyone. Today we're going to get into 8.3 day 2. So we should have done the day 1 yesterday. Just talked all about what is a vertex, what is an axis symmetry, how to find those things. And today we're upping the difficulty a little bit. We're going into how to actually graph one of these quadratic equations, how to graph a parabola, essentially. So I know I'm not in the student journal. I wanted a little bit more room. It was kind of cramped. I am doing the problem from the student journal, so if you want to follow along with me, I'm on page 259, and I'm going to start here with number 5, right? So number 5, that helps if my pen is on. All right, number 5, I've got f of x is equal to 3x squared plus 6x plus 2. Okay, so this is a totally new way of graphing. This isn't like anything we've really seen before. We're kind of used to going through and saying, okay, this is my y-intercept, this is my slope, here's my line. But for one, we're not graphing a line, so we can't just throw 2 points on our graph and connect them with a ruler and call it good. We really have to graph more of this in order to see the general shape of what it is we're going to graph. So we're going to actually need 5 different points in order to graph our parabola. And I'll show you a trick why it's not quite so bad. But what we have to do is graph using a table. Okay, we're going to have our little x, y table here. Right? And I know some of us are in the habit of saying, okay, that's -1, 0, and 1, or whatever points that we usually use, but it's actually going to be different every time when we're graphing these quadratics, when we're graphing parabolas. What we have to do is find kind of that center point, that middle point, our vertex, and then find our other points from there, find our other values from there. So let me go through. First off, let's find our vertex. Okay, we talked about this yesterday. That's our little x is equal to -b over 2a. Okay, -b over 2a. So we're looking at our original function here. So b is this middle term, or x term. So that's 6. The opposite of 6 is -6 all over 2 times a. So a right here, I have 3. Okay, so -6 over 2 times 3, so I can get that down to, I have -6 over +6, and then simplify one more time to -1. Okay, so that's not going to be the first thing I put in my XY chart. I'm going to plop that right in the middle here of my XY chart. I'm going to go to less than that. I'm going to go from -1, I'm going to go up 0, and then 1, and then lower. I'm going to go, okay, -2, -3. I want -1 to be right in the middle of all my values. I want 2 numbers higher than that and 2 numbers lower than that. I want the 2 on either side of my vertex, and that's going to be the easiest way for me to graph. And really, I don't have much of a shortcut for the first couple numbers. Okay, what I have to do is just go ahead and start plugging stuff in. Okay, I'm going to say I'm trying to find my y value. I'm really just swapping f of x for y here too. And I'm saying, okay, I have 3 times x squared, so my x for this first point, I have 1. Okay, so 3 times 1 squared plus 6 times 1 plus 2. Okay, 1 squared is just 1. We're going to go all through here. 1 squared is just 1 times 3 gives me 3. 6 times 1 is 6, and then just plus 2. All right, so that's going to give me 11. Okay, that's my first y value there that goes with 1. I get 11. All right, then I'm just going to move right on to the next one. I'm going to plug in 0. Okay, 3 times 0 squared plus 6 times 0 plus 2. Easy enough when we plug in 0, right? 0 squared is just 0 times 3. I get 0. 6 times 0 is also 0 plus 2. I know I get 2 there for that y value. Then I'm going to plug in -1. Okay, so 3 times -1 squared plus 6 times -1 plus 2. When you're plugging in a negative number, you've always got to be super careful with our sign. All right, when we square that -1, I end up just with +1. Okay, -1 squared, I get +1. Okay, so 3 times +1 is just 3. But 6 times -1, that sign does change. I get -6 plus 2. Okay, 3 minus 6, I get -3 plus 2, I get -1. And I'm just going to keep going. Normally, I'm going to show you a trick for how to skip these next two, but I'm going to show you why this works. So we're going to have to do the math here. Okay, I'm going to plug in -2. I get 3 times -2 squared plus 6 times -2 plus 2. Okay, -2 squared gets me +4. Okay, -2 times -2 would get me +4. Times 3, I get 12. 6 times -2, I get -12. Plus 2, so 12 minus 12 is 0. Plus 2, I get 2. And then one more, I'm plugging in -3, and then I'm done. Well, done with my table. I've still got a graph. Okay, 3 times -3 squared plus 6 times -3 plus 2. Okay, -3 squared. I get +9, which I'm then going to multiply by 3 and get 27. 6 times -3, I get -18 plus 2. Okay, 27 minus 18 is 9 plus 2, I get 11. Okay, so here's the shortcut I'm going to show you. Okay, so when I have this type of graphing, when I have my vertex right here in the middle, okay, my shortcut that I can use once I have these two y values, they're going to repeat on the other side of my vertex. Okay, be very careful if you're going to use this shortcut. If you know you're going to mix this up, just plug in the other points. It's not worth getting the wrong points, okay, to try and use a shortcut. But we see that these two that are just one away from my vertex, those are both 2. Okay, so I can write, I wouldn't have to do the math for -2. I would know that's just 1 over from my vertex, so I can also put 2. Same for 11 here, that's 2 away from my vertex. I can just copy that 11. Okay, we have 5 points, so now I can go ahead and graph. Right, I'm going to draw some actual lines here. Let's make this not so messy. Got my x-axis, and let me scroll up a little bit so I have plenty of room on my y. Actually, I might move that down so I know I have room. Okay, so there's my x-axis. And then let's make this my y. All right. So first off, I've got 1 and 11. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. I barely made it tall enough. Okay, and then 0, 2, -1, -1, and then another -2, 2, and then -3, 11. Okay, it should look the same on both sides. If you're plotting your points for your parabola and one side looks different than the other, double check your math because it should be equal on each side. Then you want to draw your parabola. Be careful you don't make it look too pointed. It's going to be hard on this one because it's pretty steep. But you want to always make sure it looks curved. And connect your points. It's not the world's prettiest parabola, but it gets the job done. There we have it. All right, I know each one of these is a ton of work. Again, normally we aren't going to have to plug in all 5 points. You're just going to have to plug in the two before your vertex and your vertex, right? I'm going to have us go through the day 2 assignment tomorrow. We're going to go over min and max. I think I mentioned yesterday, I think I might have mentioned we're going to do min and max today. I decided to move it to the day 3 just so there wouldn't be too much stuff today. And then there's a couple word problems, and that's about it. Make sure you have graph paper and stuff to do this on, and I'll see you guys later.